Hello dear students, how are you? Today we will discuss worksheet number 40, class 9th science, force and laws of motion. Jigyasa Didi, I have learned that an unbalanced force is required to move an object, but can we measure the amount of force involved in it? Gyan, in order to understand this, we will have to learn the second law of motion. According to second law of motion, the rate of change of momentum of an object is directly proportional to the applied unbalanced force in the direction of force. This law gives a new quantity known as momentum, which gives the relation between velocity and mass of an object. This is a vector quantity represented by p, and its direction is in the direction of the velocity of an object. Its SI unit is kilogram meter per second. Momentum p is the product of its mass m and velocity v of the object. P is equal to mv. It gives the amount of force applied on an object by equating it to the rate of change in momentum. So momentum is equal to mass multiplied by velocity. Mass into velocity. ठीक है, यदि मास ज़्यादा होगा तो मोमेंटम ज़्यादा होगा और वेलोसिटी ज़्यादा होगी तो भी मोमेंटम ज़्यादा होगा, और दोनों ही ज़्यादा होंगे तो फिर मोमेंटम ज़्यादा हो जाएगा. अगर एक भी जीरो हुआ तो मोमेंटम जीरो हो जाएगा. मैथमेटिकल कैलकुलेशन ऑफ सेकंड लॉ ऑफ मोशन. कंसिडर एन ऑब्जेक्ट ऑफ मास m मूविंग इन अ स्ट्रेट लाइन विद इनिशियल वेलोसिटी u. Let a force F be applied on it for time t, which increases its velocity to v. Then initial momentum of object p1 is equal to mu. Final momentum of object p2 is equal to mv. Change in momentum is equal to p2 minus p1, mv minus mu, and m is equal to mv minus u. Rate of change of momentum is equal to m multiplied by v minus u upon t. From second law of motion, applied force F is equal to, or applied force F is directly proportional to rate of change of momentum. F is directly proportional to m multiplied by v minus u upon t. K is a constant here. F is equal to km multiplied by v minus u upon t. A, we know that A is v minus u upon t, acceleration. So we can say F is equal to kma. If unit of all the quantities are in SI, then the value of K becomes 1. Hence force F is equal to ma. SI unit of force is equal to kilogram meter per second square or Newton. Some uses of second law of motion in our daily life. In sports of long high jump, athletes are made to fall either on a cushioned bed or a sand bed, ताकि लास्ट में वेलोसिटी कम हो जाए, उसे चोट कम लगे. कराटे प्लेयर्स ब्रेक ए स्लैब ऑफ स्टोन विद ए सिंगल ब्लो. वो स्पीड से मारता है तो ईंट टूट जाती है. पत्थर या स्लैब ऑफ स्टोन या ईंट है वो टूट जाती है. Fielders in the cricket ground gradually pulls his hands backward while catching the moving ball. इसलिए पीछे की तरफ खींचता है ताकि मोमेंटम कम हो जाए और उसको चोट कम लगे, फोर्स कम लगे. बुलेट हार्म्स ओनली व्हेन इट इज़ फायर्ड फ्रॉम ए गन. क्योंकि गन से वेलोसिटी बहुत तेज़ हो जाती है, इसलिए वो हार्म्स करती है, क्योंकि मोमेंटम बहुत ज़्यादा बढ़ जाता है. हाथ से अगर बुलेट फेंकेंगे तो कुछ नहीं होगा, बिकॉज स्पीड इज़ नॉट देयर. Example, a force acts on an object of mass 5 kg for 2 seconds. It increases the velocity of the object from 3 meter per second to 7 meter per second. Find out the amount of force applied. If the force applied for 5 seconds, what will be the final velocity? U is equal to 3 meter per second and V is equal to 7 meter per second. T is equal to 2 seconds and M is 5 kg. The force we can write. The formula of force is F is equal to m into v minus u upon t. So answer is 10 Newton. And in second case, t is 5 seconds. Then F is equal to m into v minus u upon t, and v is equal to ft upon m plus u. And after calculation, we have got v is equal to 13 meter per second. Let us discuss some question. Derive the mathematical form of second law of motion. आप इसमें ये लिख सकते हैं, ये मैं आपको पहले बता चुका हूँ. What will be the momentum of a car parked at roadside? Explain. The velocity of car stopped on the road is 0, so its momentum is also 0. The velocity of an object of mass 100 kg is increased from 5 meter per second to 8 meter per second in 6 seconds. Find out the amount of force acting on it. Mass is given 100 kg. Initial velocity u is 5 meter per second. Final velocity v is 8 meter per second. And time say 6 seconds. So force is equal to m multiplied by v minus u upon t. F is equal to 100 into 8 minus 5 upon 6 is equal to 100 into 3 upon 6 is equal to 50 Newton. The answer is 50 Newton. Question number 4. A truck of 1000 kg mass is moving with a velocity 0.5 meter per second. Calculate its momentum. Mass is given 1000 kg, velocity 0.5 meter per second, momentum m into v. 1000 into 0.5 is equal to 500 kilogram meter per second. Question number 5. Define momentum. Also write its SI unit. Momentum is the product of mass and velocity of the object. Its SI unit is kilogram meter per second.